So whenever we have a redundant path in layer 2, redundant path in layer 2, loop is very likely to happen. For example, I have two switches and just take two computers enough. Even if you have just two computers, A and B, and I got one link, no problem. But I add another link thinking that I can have some redundancy. If this link goes down, the communication between A and B will still prevail, will be still there. So even if one link goes down, the communication between A and B should not be interrupted. Because of that, I added another link. Let's say this is on F0/1, F0/ maybe 8. This is F0/2, and this is F0/1. So I got the second link for redundancy. But the problem is both cannot be active. If both are active, loop will occur. How? See, we have various services, not just one or two. We have various services that will generate a layer 2 broadcast packet. For example, if I am pinging from 10.0.0.1 to 10.0.0.2, if I am pinging from A to B, I say ping 10.0.0.2. The very first thing is going to be a layer 2 broadcast. ARP request, we call it as, which is a layer 2 broadcast. Have you seen an ARP request packet before?
Yes, I've seen it in packet capture.
Yeah, you've seen in Wireshark, right?
Yeah.
Yeah. So the destination MAC address will be what? What will be the destination MAC address of the ARP request?
It's a broadcast address.
Correct.
F dot
It's
F.
F,
So 8
F
Fs.
12 times, no, 12
12
Fs.
times, yeah.
12 hexa bit is what? 48 binary bit. MAC address is 48 bit size. So there are 12 Fs here. This packet, as soon as it hits this switch port, let's say this port is F0/3, here F0/2. As soon as it hits this port, the switch is going to flood it via all the ports, and I have two of those ports. There may be many other ports. I have this port and this port. Both are forwarding the broadcast. And see what the problem, when this packet hits this port F08, immediately switch 2 will flood it to all ports, including this. So coming back. Again, when switch 1 see it, again it will flood. Flood, 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 flood. Again, switch 2 F8 will flood, 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 flood. It will not stop. Not only one direction, it is going to be two directions. This one, which is coming like this, As soon as it hits here, again flood, 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 flooding, flooding. Again, when the blue hits here, again it's going to be flooded because it's a layer 2 broadcast. This is going to consume entire bandwidth of this two link between these two switch. And there will not be any bandwidth left for other genuine traffic to pass through. So danger of loop will make this path inaccessible. Have you seen something like that in the real world?
Not in the real world, no.
Okay, in the lab
So I have
perhaps.
seen, yeah, I have seen in the firepower IPS module
Hmm.
where it's like a DDoS attack.
Correct, correct.
Yeah.
That's a denial of service attack. So this is an example for denial of service. That's right. So what Cisco did is, not only Cisco, what the industry standard vendors, all vendors that runs the industry standard protocol, what they have done is they have made this STP to be default. The purpose of spanning tree protocol is to avoid this type of loop. So as soon as there is a chance of loop is identified, STP will start running. But every vendor don't have the same STP flavor. We got 4 different flavors of STPs. One is IEEE 802.1d standard, which is a classical standard of STP. The other one is the Cisco's per VLAN spanning tree, which is also flavor of this .1b. But this is Cisco's. Now, what is the difference between these two? In this, whatever the number of VLAN you may have, there will be only one instant STP. Whereas in Cisco devices, the same IEEE 802.1d is slightly modified to have more number of STPs. How many? Depending on how many VLANs you have. 5 VLANs, 5 instances of STP. So number of VLANs is equal to number of instances of STP. All other things are same in between these two. What are all the other things we'll discuss later. So this is two flavor. Now, next. IEEE 802.1s, IEEE 802.1w. These are the other two industry standard protocol. Standard protocol. Now, one S is rapid spanning tree protocol. You can also say RSTP. And then multiple VLAN spanning tree, which is also called as MST. Now, in some vendors, I've seen rapid as the default. Even in Cisco, some advanced devices have got rapid as the default spanning tree. But all enterprises devices I have noticed, they have this per VLAN spanning tree by default. And MST we need to configure if we want. So there are slight variation in their behavior, which we are going to see now. So we have these 4 different flavors of STP. That's what I want to tell. There are 4 different flavors of STP. Classical, as I said, only one spanning tree for any number of VLANs. What is the problem with that? Load sharing cannot be done. How load sharing? We'll talk about that later. Whereas in per VLAN spanning tree, because you got a separate instance of spanning tree for each VLAN, you can tune it for some VLAN to have different path. In that way, you can do load sharing. Now, what is the advantage of RSTP? As the word says, rapid. Rapid spanning tree protocol. Rapid, fast, rapid. So compared to the above two, this is faster. How and all we will talk later. Now what about MST? See, rapid spanning tree is not only rapid, it is also per VLAN. If I have 100 VLANs, then 100 rapid spanning tree in Cisco. 100 rapid spanning tree will be running. See, I'm repeating, this is all in Cisco. I have seen some vendors, when you have rapid spanning tree, then do only one instance of rapid spanning tree for all VLANs. But Cisco is modifying this RSTP. It is RSTP PVST plus. That's what I want to say. In Cisco, rapid spanning tree is per VLAN. There is a drawback in this. What? The CPU utilization. Because you got fast and many fast spanning tree, and how many? If I have 100 VLAN, 100 times faster. CPU utilization, 100 times fast. Oh. To reduce that CPU utilization, we can reduce the instance of rapid spanning tree by using MST. In MST, for 100 VLAN, you no need to run 100 spanning tree. If you want to run only 2 spanning tree, or 5 spanning tree, or 4 spanning tree, you can do that. For example, I'll group this 100 VLAN into 4 groups, 25, 25, 25, 25 each. And for each group of VLAN, I can give 1 instance of spanning tree. So I need only 4 instances of spanning tree. 4 instead of running spanning, rapid spanning tree instead of running 100 instance. Very big difference it will make. 400, it's too big difference. So we are going to see one by one. First, let us see how spanning tree prevents loop. So this will be W and this will be S. Rapid is W and MST is S.
All right. Okay.
Now, we cannot always have this IEEE 802.1d standard PVST plus. You should not imagine you should go and verify. Depending on the series of switches, the default will vary. I've seen in some like Nexus, the default is rapid, IEEE 802.1W. And I have seen many switches in the enterprises with this PVST plus as default. I have also seen one vendor, I'm not sure which one, Huawei or ZTE or which one, MST is default and all VLAN will be mapped to that one single instance of spanning tree. If you want, you can create more instances and put those VLANs that you want to put in different groups. Right? So we got different flavors of STP. Now let us take the above example. I can draw this better. Now I'm going to connect this PCs to the switch F0/1, F0/2, F0/1, 2. And the IP on this computer is 10.0.0.1, 10.0.0.2/16. And IP on this other department is 10.0.10.1, 0.2/16, 10.1, 0.2, so 1/16. Let's say the MAC address on this computer is A. Now we all know that in order to carry multiple VLAN traffic, we need to have a trunk link. So I got a trunk link here. And let's say F. So this is a trunk link. Traffic is of VLAN orange. Let's say orange is 10. And the purple is 20. The traffic of both VLAN 10 and 20 is now going through this trunk link. We saw how trunk is negotiated. But for the sake of redundancy, I am introducing another link for 20. I'm simply randomly writing some number. There is no planning involved here. Fine, we got this type of redundant path. And we all learned that the loop will happen. To prevent loop, STP is going to come and block one of the port. Yes. By blocking one of the port out of the 4 ports, on the trunk link, how many ports we have? 4 ports. Out of this 4, only one is going to, only one port is going to be blocking port. What is the use of blocking? When you block the port, that links go inactive. That link which has got the block port, that link will go inactive. In STP language, you can say that link will not be active, it will be used for use a standby. Use a standby. But to decide on which port to block, whether to block F05 or F08 or F03 or F03 on the other switch, to decide on which port to block, there is a procedure STP follows. What is that? First is it will make one of the switch as a root switch. Root. What does that mean? I do not want to block. That's the meaning of the root switch. See, will anyone block the root? If you block the root, no branches will be able to receive minerals and water from the soil. If someone wants to cut, they will cut on the tip of the branches. Blocking should be done only on the tip of the branches, not on the root. So what does that mean if it elects a root switch? It elects a switch where the blocking cannot be done. So you have 4 ports. If you decide any one of the switch as a root switch, already 50-50 is over. Out of these 4, 2 cannot block because it's a member of root switch. So blocking will happen on the other opposite, any one of the other opposite 2 ports. Okay. Now which switch is the root switch? Which switch is going to be the point of reference for all other switches? Which switch is not going to block the port? To decide that, spanning tree will look deep into the BPDU's bridge protocol data unit. The switches will look deep into the BPDUs of every port that comes from all switches. Yes, all switch will send BPDU, not just one. On each link, it will send one BPDU packet. It will be sent every 2 seconds. On every port, every wire of switch A and switch B, even on the wire that connects to the computer, the orange and the purple, on every wire, there is a tiny packet called BPDU, Bridge Protocol Data Unit, sent. What does this BPDU carry? Most importantly, it carries the priority of the switch, bridge ID of the switch, port priority of the switch, port cost of the port, timers, etc. So in that, now the switch A will know about switch B's priority and switch B will know about switch A's priority. We compare the priority. Let's say the priority, the default is, not let's say, this is what default is. 3, 2, 7, 6, 8. 3, 2, 7, 6, 8. This is the default priority. Whether it is Cisco or non-Cisco, as per the standard, this is the priority. You know why? Out of 16-bit, which is given for VLAN and the priority in layer 2, the higher order 4-bit is for priority. In that, the left extreme bit, which is 2 to the power of 15, out of 16-bit, it starts from 2 to the power of 0. So the 16th bit is 2 to the power of 15. If you see 2 to the power of 15 value, 2 to the power of 15, it is 32768. Yes. So 16th bit from the right, 15th bit from the right. Means if you start from 2 to the power of 0, 16th bit from the right is on by default. Let me repeat that what I said. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16. This is 2 to the power of 0, this is 2 to the power of 15. This bit is on, and these 3 bits are 0. These are the 4 bits that are given for priority. And this is 2 to the power of 11. 2 to the power of 0 to 2 to the power of 11 is VLAN. If you see 2 to the power of 11, it is 2192, I think. 2 to the power of 11, let's see. 2 to the power of 11. Yeah, 2048. Huh? 2048. And the next bit is 4096, which means the sum of all the face value will give you 4095. That's why the reason for why the maximum number of VLANs that you can have is 4095. VLAN number 1 is default. You can create VLAN between 2 to 4094. 5 is reserved. There are some VLAN numbers reserved. So the reason why you cannot have more than 4095 is 4096 is not for VLAN. It is given for STP priority. So only this bit from 2 to the power of 0 to 2 to the power of 11 is for VLAN marking, VLAN IDs. So any switch you take, you will not be able to create more bigger number than this 4095. This is the biggest VLAN number. So about the priority, this bit 2 to the power of 15 is on, all the rest are 0. That's why the default priority is 32768 on all switches as per the standard. If you would have gone to any one of the switch and made the priority as 0, then this would have become a root switch. If this is a root switch, this will be forwarding, this will be forwarding. But what if I did not set the priority? If the priority is not set, it is going to compare the bridge ID. In another word, you can call MAC address. So in this BPDU, the MAC address of the switches are also being shared. Let's say the MAC address of this switch A is 1AA. The MAC address of switch B is 2AA. Which one is smaller? This is smaller. So this will become the root switch. If this is the root switch, then this will not be blocking, this will only forward. So there won't be any blocking port on the root switch. Root switch will always have forwarding port. So the blocking, if need to be done, it needs to be done on the other side, not on this root switch side. See, we are trying to understand how STP is going to decide a blocking port. This all happens very fast in millimicrosecond speed, but we are just learning it, spending many minutes so that you can tune STP as per your wish. First, the STP will compare the BPDU's priority on each switch coming from each switch. The switch with the lower priority is lower, small. One thing you need to understand without confusion, spanning tree will only like small. So you can remember like S, spanning tree, S, small. Both start with S. Spanning tree is small priority. If the priority is same, then it is going to be the MAC address. Small MAC address again. Switch A's MAC address is smaller 1AAA. So switch A becomes the point of reference for switch B, which means what? This port and this port will be in forwarding state, designated to forward. And if you don't like this decision, you can go to the other switch and decrease the priority. See, before checking the MAC address, before comparing the MAC address, the switches will compare the priority. So when you do changes to the priority, then you win. Yes, you win. Whatever you configure is what going to be a decision maker. Anyway, let us assume that priority is same and the MAC address is a tiebreaker. Now switch B is going to block one of its port. How? Now from switch B perspective, switch B will see which link among these two, which port, which link is the best port to reach the root switch, whether it is best via F03 or F08. Switch B will now see the cost on the link. Switch B will see the cost on each link. Cost. What does the cost mean here? So based on the bandwidth on the link, there is a predefined value. We call it as STP cost. For example, when we have 100 meg, the STP cost will be when it is
19.
1 gig 4. For 100 meg, 19. For 10 gig, 2. For 10 meg, 100. So likewise, the cost is the numerical value given by the STP, the standard, to differentiate, to provide more importance to high bandwidth links. High bandwidth link will have low cost. As I said earlier, smaller is spanning tree. It likes small things. So if I have one link as gig link, the other link as fast Ethernet, it will pick the gig link as the root port. What is root port? Will I see a root port on the root switch? No. Root port is a port that is designated to connect, to communicate to the root switch. But in our case, we don't have different speed link. The link speed is same. The link speed is same, 100 meg. When the link speed is same, 100 meg, what it is going to compare? Both are 19 and 19. When the link speed is same, switch B will compare the port priority. The port priority. The incoming port priority matters. Switch B will look into the incoming. What does it mean? Switch A will be sending a BPDU via F05. Will also send another BPDU via F013. Sorry, F03. Switch A is sending two BPDUs. One via F0/5. The other one is via F03. The one which is coming via F05 will bring the priority 128.5. The one that is coming from switch A F03 will have 128.3. Now switch B will pick the path which is bringing the small port priority, which means switch 8 is, sorry, F08 is root port, because it receives a low cost compared to switch 03, sorry, F03. F03 receives 128.5. Dot 5 is bigger than dot 3. So if this is the root port, then this is going as what? Blocking port. Switch B, F03 is blocking. So there is a mistake some many people does. What is that? When we say port priority, they will say, okay, this port priority is cheaper than this. No, no, no. It's not local port priority. It's the incoming port priority. Incoming. If you see incoming, then this is the root port. And this is blocking. When we don't understand this proper, then you will find this, you will think that this will be a root port and this will be blocking. And when you go and check the switch, it will be opposite. Why it is opposite? Because you are looking into the local ports cost. You need to see the incoming port cost, not the local port cost. Incoming port cost on F08 is smaller than the incoming port on F03. Is this clear? Do you have any question?
So the first thing when it comes to root port election on switch B, the first thing it will check is the cost of the link, and the cost is same. So the next thing will be incoming port priority.
Correct. That cannot be seen.
Yeah. So the how the switch decides on the incoming port priority, because
BPD is bringing
okay,
it.
and is it something set by default per every port, or is it?
Yes, it is set by default. You can change
I
it.
can change it. Okay.
We can change it. We'll be doing such exercises
Yeah.
by the end of STP topic. But as of now, we are learning the fundamentals how STP by default works. Right? This is default. But we are learning these things so that we can go and tune it as per your wish.
All right. Great. Yeah.
We can have the port that you want to be a root port by tuning this type of priorities. Even the STP cost can be tuned for a link, or you can tune the port priority. It's your wish. Whichever you're comfortable, you can tune. Right? Okay. So this is about normal. This is the story which is common for every spanning tree, all four flavors of STP. All four flavors, all four will behave the same way. Whether it is MST or rapid spanning tree. STP, whether it is single instance or many instance, or single VLAN or multiple VLAN, this is going to be the procedure for electing for choosing a blocking port. So what happens now when this link is blocked? This goes as a standby link, and this is active. Now, one important thing is, because there is a block in that F03 switch B, we should not assume ourselves that the port is in a shutdown state. No, no, no. The port is not in a shutdown state. Even now, the management protocols are still running between F05 and F03. The line protocols, the keep alive, they are still there going in between F05 and F03. The link is up, but the control plane of the switch is not allowing the packet to flow through the port. Who is the control plane here? STP. STP is the control plane that is controlling the packet to flow through F08, not via F03. Likewise, if any packet comes from switch A to F03, it's not going to take the traffic in. Switch B is not going to take the traffic in if any traffic comes on port F03. Because it's in a blocking state, the control plane will not permit. Right? So what we have seen so far is the basic steps in which STP makes a link as active and all the other links as standby. See, right now we have only one active on standby. What if I have 10 links? All 9 will be standby. Except one link, all 9 will be standby. This is how STP works, right? So let's quickly do a lab and see. Even a packet tracer is enough for doing a normal STP lab. Let me bring a packet tracer to show what we have seen now. Now when we take two switches and connect wires like we said, like F05, I'm connecting to maybe F01, and likewise I connect
So you're recording this session, isn't it, sir?
F02, yes,
Right.
yes, F02, I'm connecting to maybe F017, and wait, I would like to name the switch as SA, switch A. Okay. So we got switch A and B. Now we do not know which one has got what MAC address, and we know the priority is same on both the switch because we have not done any change to the priority. Now let me simply go and give the host name. Switch A and switch B. So we got two switches and the show spanning tree. When you see there are two portions of this output, the top portion is talking about the elected one. You should not focus on that. Now this is the one which is of this switch, the switch which you are checking. This is the MAC address and this is the priority 32768. And this is the MAC address. So let me copy the MAC address and paste it. Here. And likewise on switch A, show spanning tree, I copy the MAC address here and paste it. Right now, when the priorities are same, the MAC address is going to be compared. When we compare, we can see here, this is 0001. This is 000012. C is 12. Definitely 1 is lower than 12. So this is the lowest MAC address switch. If this is lowest MAC address switch, as per what we have learned earlier, the switch with the low MAC address is the root switch, isn't it? Root switch. So root switch, then this is going to be called as designated port for designated for forwarding. Designated forwarding. Let's go and verify this. I should see designated forwarding exactly. Designated forwarding. And the cost on the link, the spanning tree cost on either side is 19 and 19. So the cost on the link is 19. Now, this switch will compare the cost because the cost is a tie. This is going to look for the incoming port priority. Let me show you. The priority on this port is 128.5 on F02, F05. And F02 is 128.2. So switch B receives low priority on
F02.
F017.
Yeah.
No. F017 is the one which receives the low priority. Low priority. So F017 will be considered to be
designated forwarding port. Yeah.
Designated root port.
Okay.
So this is not a designated, this is a root port forwarding. It's root port forwarding. Root port you will not see on the root switch. Root port is on the other switches that connects to the root switch. So switch B connects to the root switch via F017. So this is going to be the alternate port blocking. Let's go and verify that on switch B. Switch B, look at this. F017 is root port forwarding. F01 is alternate port blocking. So it compares the incoming port priority. Lower incoming is on F017. If you don't understand that incoming, then you will think this will be the root port because this is small priority. That's wrong. Incoming method. So you're comfortable with this?
Yes, sir. I'm okay
Simple
with that.
spanning tree. So this is how IEEE 802.1d works, but actually we have per VLAN spanning tree by default enabled. Even though here it says IEEE, it is IEEE based. IEEE slightly tuned to have a new flavor called per VLAN spanning tree. So it is not IEEE 802.1d working, it is IEEE 802.1d's flavor called per VLAN spanning tree. Let me show you that. Now, if I create multiple VLANs, VLAN 10, VLAN 20, so we have now 3 VLANs. Here also VLAN 10, VLAN 20. We have three VLANs, and I'm going to have a trunk link interface range F0/1, F0/17 switch port mode trunk. Now show interface trunk. We got trunk, and this trunk is allowing these three VLANs now. Now see, there's a role change happening. Let's wait for this port to become green. Once it turns green, then we'll verify. Now let us go and see on switch B, whatever we learned is still the same, but it will be there for every VLAN. Show spanning tree. Now you can see many VLANs, and there is a separate instance. For VLAN 1, this port is blocking. For VLAN 10 also, the same port is blocking. For VLAN 20 also, the same port is blocking. We have different instances, that's why it is showing separately.
Yeah.
So if you want to go and tune only for VLAN 20 so that there won't be a block on the usual place, you can do that, which we are going to see after some time. But now, per VLAN spanning tree is what runs on every switch. If someone says Cisco switches run F888.1D, they are partially correct, because the per VLAN spanning tree strictly follows that same standard IEEE.1D. The only difference is the number of instances. Now, let's go and make this switch as the root switch. Right now, switch A is the root switch. How do I know? Show spanning tree. When you say show spanning tree, and you will see the MAC address of the root switch and the local is the same, which means this bridge itself is a root. That's why the MAC address is same. I said the upper portion will always talk about the root switch, because the switch itself is a root switch. Because this switch itself is a root switch, it is shown here. Whereas the other switch have got different MAC address. Show spanning tree. The upper portion and this portion MAC address is not the same. This means that the switch with this MAC address is the root switch, and that particular switch is connected via F017. If you go down and see, that's the root port. Okay, 0/17.
Yeah.
Now, if I want to change switch B as the root switch, what should I do? You cannot change the MAC address.
Lower the priority.
What you can do is you can change the priority. But before that, I would like to show you the priority here. The current priority is 32768, then why it is showing 32769? Always the system ID, which is nothing but the VLAN ID, the broadcast domain ID. Every VLAN is a switch here. Every VLAN is a switch. Switch is identified with a number called VLAN number. VLAN number 1, and if you go down, it is VLAN number 20. For VLAN 20, it is 20. That is how the broadcast domain is identified, and VLAN 10 here. We call system extension ID. That is always getting added to the priority. So for VLAN 10, the priority will be 32768 plus 10. For VLAN 1, it is going to be 32769 because system extension ID is 1. So it's always the VLAN ID added in priority. Now, I can make switch B as the root switch for any one of this VLAN or all of the VLANs. Let's see how to make only for VLAN 20. For VLAN 20, currently if I say show spanning tree for VLAN 20, I see switch B is blocking. This is not the root switch. But when I go here and say spanning tree for VLAN 20, priority 0. So only for VLAN 20 I change the priority. Now if you check here, for VLAN 20 the priority is 0 and the system extension ID is 20. As a result, the total priority itself is 20. So this has become a root
Root switch,
switch.
yeah.
If it is root switch, it needs to be forwarding. You will see soon this will turn to forwarding. See, both are now in a listening state and learning state. And okay, forwarding, learning, learning. LRN is learning. Okay, forwarding. Now, both are forwarding. If both are forwarding, then blocking will happen on F02 of the other side. Listen. For VLAN 20 alone, we are now talking. This is the root switch. This is forwarding, this is forwarding. So the lowest incoming priority is on this port. So this is going to be blocking. So for VLAN 20, this is the path. For VLAN 10 and 20, that is not a path, that is blocking there. For VLAN 10 and VLAN 1, not 1. For VLAN 10 and VLAN 1, this is blocking. But for VLAN 20, it is forwarding. Whereas this one is blocking for VLAN 20 and forwarding for 1 and 10. Let's verify that. We will go first to switch B. Now in switch B for VLAN 20, you see both are forwarding, whereas for VLAN 10, it is blocking. F01, the upper path is blocking.
Yeah.
VLAN 1, upper path is blocking. Whereas on the other switch, it is the opposite. On switch 1, show spanning tree for VLAN 1, the bottom path will be forwarding. 10 also bottom path will be forwarding. And for VLAN 20, the bottom path will be blocking. F02 is blocking. So in this way, you can do kind of load sharing. This is load sharing actually. Both the links are now used.
Just, yeah.
No links are idle. This is the beauty of, this is the advantage of Cisco's per VLAN spanning tree over IEEE 802.1d standard. Now it's a similar story when you bring another switch. When you bring another switch and connect here, I'm going to connect another wire here. And switch 2 is going to be a trunk. I call this a switch. host name switch underscore C, interface range F0/1-2, switch port mode, and then VLAN 10, VLAN 20. So all these three switches are running 3 VLANs. Now I'm going to remove the priority that we set on switch B. I do not want to have it anymore. So now it's only the default priority everywhere. And I want to know the MAC address of switch C. Show spanning tree. Now this is the MAC address of switch C. Now when we compare the MAC addresses, we see switch A's MAC address is the smallest.
Smallest, yeah.
So even now switch A is the root switch. Fine. If switch A is the root switch, this is going to be forwarding designator, this is going to be designated forwarding. Now what will happen is the other switches will try to find the low cost path. For switch C to reach the root switch, this is 19. If it goes like this, it is going to be 19 plus 19 costly. It won't go there that way. So switch C says, I'll consider this as a root port. Likewise, switch B will say, I'll consider this as the
Root port.
root port. Now, there is a chance of getting blocked here on switch B or switch C. Where should it block? Again, the same story, the smaller wins. Switch B has got smaller MAC address, so this is going to say, hey, you got a smaller MAC address, so I'll be calling this as designated forwarding port. So this will say, okay, fine, I'll call my port as alternate block, because the MAC address is bigger. Here, the cost is cannot be compared. You don't have another link to compare the cost, the link cost, the port cost. Not possible. You understand?
Yeah.
So it compares only the MAC address, the bridge ID. Because there's a priority same on switch B and switch C, it compares only the bridge ID, the MAC address. The one with the lower MAC address will not block the other one blocks. Let's go and verify that. We need to see switch C F2 blocking. I can see the red dot already. Switch C for VLAN 1, should see, yes, should see F02 should be blocking. It is blocking for VLAN 1. Let's check for VLAN 10. Even now it is blocking for VLAN 10. Let's check for VLAN 20. Even for VLAN 20 it is blocking. Now this is how the spanning tree prevents loop by blocking ports. So what we need to see in spanning tree next is the load sharing. For that I want to use different topology. We'll keep this down. I'll bring another switch here. So we got two paths to reach. So what we can do is, if we have VLAN 10 and 20, this VLAN 10 should use the upper path. VLAN 20 should use the below path. these two down PCs of VLAN 20, they will use switch C as a path. These two PCs on the up are VLAN 10 members, it will use the upper path. For that, what we have to do? What we need to do? You see, this is VLAN 20, VLAN 10, VLAN 20. Simple. Go here and decrement VLAN 10's priority. Let's say VLAN 10 priority is 0. And here I'll say VLAN 20 priority
to 0. Yeah.
0. And here I'll say VLAN 20 priority 1024. No, you cannot do that. 4096. And for VLAN 10 here, priority 4096.
Okay.
The reason why you cannot increment with any middle number, as I said earlier, from 2 to the power of 12 onwards, given for priority. So you got only 4 bits for priority. The down
VLAN.
bits are only for VLAN marking. So if all are 0, you get 0. And what is the least one? This one is the least one. What is 2 to the power of 12? 4096. Either you make all 0 or you keep incrementing by 1 here. Sorry, you keep incrementing by 4096 because this is the place from where the priority bits. So priority cannot be 500 or 1000. It should be an increment of 4096 only.
Yeah.
Okay. Right. So this is what we are going to do now. And this is the newly added switch. Our focus is not on VLAN 1, only on VLAN 10 and 20. Interface range 0/1 -2. Am I right? Yes. Switch port mode from VLAN 10, VLAN 20. Host name is switch. I would like to call it as D. Now, as I said, I'm going to set priority spanning tree for VLAN 10. Priority is 0 because I want VLAN 10 traffic to go by the upper path. Spanning tree for VLAN, oh, I said 20, sorry. 10, 0, 20, 4096. You can also put question mark and say priority cannot be any number. It should be only increment of 4096. The reason is
The bit.
the bit given for priorities is from 2 to the power of 12. If I try saying 500, see what happens. It says these are the numbers you can use. So it's a clue. You don't need to increment. It increments and shows you. Right? Increment of 4096. Okay, done here. Now let's move on to the switch at the bottom. Spanning tree for VLAN 20, priority 0. Spanning tree for VLAN 10, priority 4096. Now, what we are expecting will happen. No ports are blocking for some VLAN, yes, they do block, but for the other VLAN, they are forwarding. For example, for VLAN 10, for VLAN 10, this is going to be the path. This is the control plane's decision. For VLAN 20, this is going to be the path. Blue is VLAN 20. Red VLAN 10. So we got red and blue. And I'm expecting a block for blue on switch D. No. Somewhere on the upper path. It may be switch D, depends on the MAC address. I don't know the MAC address of switch D yet, but I have changed the priority. The other switch will not have priority other than the default. So I just want to verify once. Switch D show spanning tree for VLAN 10. I'm expecting forwarding. Yes, it is. Let me copy the MAC address to the board. Whereas for 20, I'm expecting a block. F02 is blocking for VLAN 20. For VLAN 10, it is forwarding. On the other hand, switch C shows spanning tree for VLAN 20, it will forward, whereas for the 10, it's going to block. It is blocking. Right, this is how we can do load balancing. But there is another way of setting priority, which we'll see in our next class. There's another way of setting priority by giving command called spanning tree VLAN 10. Instead of saying priority, we have root primary and root secondary. There's a command called primary and secondary. So when you say primary, 8,196 will be deducted from the default, and when you say secondary, only 4,000 will be deducted. So when you subtract 8,000, then the priority becomes very small than subtracting from 4,000. Anyway, we'll see those things